In this video, I want to talk a little bit about transcription initiation in prokaryotes. We talked a little bit about the transcription machinery in the previous video of prokaryotes and eukaryotes. So we're going to elaborate on the prokaryotes here through this diagram. So if we imagine that we have double-stranded DNA. Let's think that this strand up here that has the 3' end on the left side and the 5' end on the right side, let's imagine this to be the template strand. Now this up here is going to be the holoenzyme. And if you recall, the holoenzyme is made up of the core enzyme, which, if you recall, has 2 alpha subunits, an omega subunit, a beta subunit, and a beta prime subunit. And the blue portion here is the sigma subunit that's specific to particular genes. Now, if you recall, the sigma subunit's purpose is to help the core enzyme bind the promoter region of the DNA. So if we imagine this region here to be the promoter, the sigma subunit is going to help the core enzyme bind. When it binds, it forms this thing called the closed complex. And the reason it's called the closed complex is because these 2 strands of DNA are wound around each other and have not been separated. So what needs to happen now is the helix needs to be unwound and forms the open complex. So once we have this open complex form, the RNA polymerase, the holoenzyme, can begin to make RNA. So it adds a few nucleotides, and this here in blue is, of course, the RNA that we're making. So it begins to move forward, and forward in this case is heading this way because it's reading this template strand 3' to 5', so it's going to add bases that are complementary 5' to 3'. So after a select few nucleotides are added, the sigma subunit leaves. So this is the sigma subunit here. So after a few nucleotides, NT stands for nucleotides, are added, the sigma subunit dissociates. It falls off. Because it did its job. The sigma subunit was solely supposed to help the core enzyme bind, and once it gets going, once the core enzyme gets going, the sigma subunit is no longer necessary. So the core enzyme continues on and polymerizes RNA. So what end here is the free end of the RNA? That end is the 5' end, because the RNA polymerase is making things 5' to 3'. So that means the first thing that it made was at the 5' end, and it keeps adding things to the 3' end. So then what? Then what happens? Well, then it's elongation. Elongation is just the idea that this RNA polymerase is going to continue adding nucleotides. It's going to keep adding them. It's going to keep adding nucleotides. And when I say keeps going, I'm talking about the core enzyme. It keeps going until a termination site is reached. And that's about it for initiation of prokaryotes, initiation of transcription in prokaryotes. I hope that video was helpful. One last thing, I am a tutor. If you live in Southern California, feel free to contact me via email at moofuniversity@gmail.com and see the description below for more details. Thank you for watching.